The way that Bolstad defines a global function is one where you have an input grid, you find some sort of element of it, such as the global maximum shown here, and then you assign that value to all grid cells in the output grid. Bolstad points out that this could be useful, for example, if you were trying to determine the maximum temperature in an area and then you wanted to see how much lower the temperature was around the entire area. You could use that output grid, the global maximum, subtract the input grid, and see the difference. However, there are other ways to do things besides having a new output grid that all grid cells have the exact same value. An alternative to this could be in ArcGIS Pro to just use a raster calculator. In this example, you could put in the global maximum as a constant and just say 42 minus the input grid, and you would get that same result. It's also worth mentioning that Esri defines global functions in a different way. With Esri's global functions, there are varying values in the output grid. It's not all one value, as Bolstad explains. And the default for these raster processes for things like hydrologic analysis and other analyses are the full resolution and extent of the input grids. And so they can sometimes take long processing times and take a long time to run. If what you're looking for are global statistics, such as the minimum, the maximum, the mean, all those sorts of things, you can just either calculate the statistics on the grid that you're interested in that for, or you can, or the statistics may have already been calculated and you can just look at the properties. So that's just kind of an alternate approach to this idea of a global function returning a grid where all the grid values of the output grid are the same.